On May 19, 2026, Google announced the most significant architectural overhaul to its search engine in 30 years. The traditional list of blue links was swept aside, replaced by an internet mediated almost entirely by the conversational interface of the new Gemini 3.5 AI model. Across Silicon Valley, Anthropic was executing an aggressive countermaneuver. They brought on Andrej Karpathy, an elite engineer known for directing AI and autopilot vision at Tesla. His new mandate was highly recursive: build a division where the Claude model actually designs and optimizes its own future training architectures. This tiered diagram illustrates the mechanics of Software 3.0. It shows the transition from humans writing explicit logic to a system where the neural network acts as the primary host process. Traditional code modules act merely as coprocessors, rendering human coding increasingly obsolete. While tech executives spent the day celebrating the impending automation of software engineering, they completely missed a fatal flaw in the system. The automated agents designed to write the code were evolving rapidly, but the physical and digital deployment environments built to host them were brittle, exposed, and quietly cracking under the pressure. On the exact same evening, a financially motivated cybercriminal syndicate known as TeamPCP successfully breached the most trusted vault in the developer ecosystem, GitHub's internal proprietary network. Operating with absolute brazenness on cybercrime forums, the group posted a massive data cache. They demanded $95,000, threatening to freely leak over 3,800 private internal organizational repositories if a buyer wasn't secured. The terror of this intrusion was its simplicity. The attackers didn't burn a highly complex zero-day vulnerability against GitHub's heavily guarded server infrastructure. Instead, they compromised a single poisoned Visual Studio Code extension installed on one individual employee's local workstation. The GitHub breach was part of a broader, highly coordinated assault targeting the local tools engineers use every day. The primary entry point was the weaponization of NX Console, a heavily relied upon workspace management extension boasting over 2 million installations and a verified publisher badge. Using a stolen authentication token, the attackers pushed an orphan commit, a hidden string of code that bypassed standard security reviews. This commit slipped a tiny 498 kilobyte JavaScript payload directly into the extension, which then automatically updated itself on developer machines worldwide. This split-screen comparison shows exactly why standard enterprise defenses failed. On the left, traditional endpoint detection systems easily spot and block compiled malicious binary files. But on the right, the malware operates entirely as plain-text JavaScript, executing routine actions like reading environment variables. Because reading a text file looks completely benign, the security software registered 0 anomalies, while the script quietly drained corporate secrets. The payload was highly specialized. To evade domestic cybercrime prosecution, the developers engineered a geographic fencing mechanism into the code. The moment the malware detected a machine operating in a Russian or CIS time zone, it aborted execution completely. The global security community identified the anomaly with stunning speed, pulling the extension from the marketplace in just 18 minutes. But in a landscape of auto-updating software, 18 minutes is an eternity. Any developer who opened their code editor during that brief window was instantly compromised. The assault then escalated mathematically. TeamPCP launched a massive wave of attacks utilizing the mini Shai-Hulud supply chain worm, specifically targeting Alibaba's foundational data visualization libraries housed on the global JavaScript registry. This node graph visualizes the worm's exponential replication cycle. Starting with a single infected laptop, the script harvests the developer's configuration tokens. It automatically maps out every software package that victim has the rights to publish, injects its payload into those legitimate packages, and instantly republishes them back to the registry to snare the next set of victims. When standard network firewalls blocked the stolen data from leaving the corporate network, the worm used a fallback. It leveraged the victim's own stolen authentication tokens to dynamically generate hidden, rogue repositories directly on the victim's personal account, pushing the encrypted secrets there instead. TeamPCP even hosted a public competition, offering cryptocurrency bounties to anyone who could use their source code to execute the largest supply chain compromise. By crowdsourcing the operation, they turned ordinary, compromised developer laptops into unwitting launchpads, ensuring their attack patterns would spread rapidly across the internet. While engineers scrambled to patch their local code editors, the broader infrastructure hosting their applications began to buckle. On May 19th, Railway, a widely used modern platform for deploying applications, suffered a catastrophic service disruption that lasted for 8 hours. An opaque, automated risk management action from Google Cloud Platform triggered the disruption, incorrectly flagging and suspending Railway's core production account without warning. Railway operated its own physical servers across multiple global sites. Yet, because they relied on a centralized Google Cloud API for basic network route discovery, that single localized suspension cascaded outward. It proved that relying on the algorithmic governance of a major cloud provider carries the constant, latent risk of a total global shutdown. The most severe implication of the May 2026 attacks connects directly back to the industry's obsession with automated code generation. Hackers discovered a way to establish deep ambient persistence directly inside AI developer tools. This pipeline diagram demonstrates how the attack works. The Shai-Hulud payload intentionally targets deep developer configuration files, specifically modifying a text document called .claude/settings.json. By altering this simple file, the malware effectively backdoors the developer's local AI coding assistant, subtly injecting malicious logic into a completely clean workflow. The trap is highly resilient. Even if a vigilant engineer deletes the malicious package, the compromised AI agent remains active. It silently rewrites the vulnerability back into the source code during autonomous coding sessions. Threat actors successfully weaponized the very automation Anthropic and others are rushing to build. The attacks proved that in an environment where models generate code, a compromised AI configuration file becomes a persistent vulnerability, reinfecting the source code every time an engineer uses their assistant. The synchronized events of May 19th and 20 proved that traditional reactive vulnerability management and network-level firewalls are mathematically insufficient to stop modern, self-replicating supply chain attacks. Securing this environment requires deterministic endpoint-level enforcement. Security platforms are pivoting toward deep kernel-level workstation inspection, injecting certificates directly onto the developer's device to monitor and sever malicious encrypted traffic before it ever leaves the local code editor. Scanners that read code after it's downloaded are too slow. Organizations are now enforcing strict install time defenses, such as rolling 48-hour age blocking policies. By automatically quarantining any newly published package for 2 days, they neutralize the brief time advantage attackers rely on. The technology industry is aggressively pushing toward a highly automated future, but until engineering teams begin treating the individual developer's laptop as the ultimate zero-trust perimeter, the entire software supply chain will remain critically vulnerable to total systemic collapse.